everybody, this is section 7.4, proving triangles are similar. And here we will use the angle-angle similarity postulate, as well as the side-angle-side similarity and side-side-side similarity theorems to prove triangles are similar, and then also use similarity to find indirect measurements. All right, so in the past, we used the angle-angle postulate to prove the third angle was congruent. However, we had talked about it at the time, and I said, you can prove angles are congruent, but you cannot prove that triangles are congruent through the angle-angle-angle postulate, because even though the angles are congruent, the sides may not be the same, which, if we look at the similarity statement, we know that all three angles are the same, but the sides are in proportion to each other. So here, we have the angle-angle similarity postulate. And this says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So we can prove they're similar, but we cannot prove they're congruent. So here we have a picture, and they want us to determine if the two triangles are similar. And we have triangle RSW and VSB. We do know that angle R and angle V are congruent, and they're corresponding because they're in the same spots on the naming, and they're 45 degrees. Now, they did not give us any other measurements, but angles 1 and 2, again, think about it. What kind of angles are those? Those are vertical angles, and we know that vertical angles are congruent. So therefore, I know that I have two pairs of congruent angles. So angles, these two triangles are congruent through the angle-angle postulate. All right, so again, we are going to determine whether the two triangles are similar. So I have triangle JKL and triangle PQR. I do know that we have in triangle JKL, angle J corresponds to angle P. So J is 30 degrees, and P, we don't know, but they should be congruent if the triangles are similar. Let's see. We do know that angle L, where I do have both measurements, is 70 degrees, and it corresponds to R. So those two angles we know are congruent. So really, it's now figuring out the measure of angle P, since I know measure of angle Q, and Q and K should be the same if the triangles are similar. So let's find the measure of angle P. If I do, if I take 180, and they show it here, subtract 85 and subtract 70, I get a 25-degree angle, which would be the measure of angle P. And right there, I know that 25 does not match up with 30, so that these two angles are not similar. Next, we have our side-angle-side similarity theorem. And when you write it out on a proof, you can just put your SAS with the similarity symbol. And that says if one angle of one triangle is congruent to an angle of a second triangle, and the sides that include the two angles are proportional, then the triangles are similar. So again, the sides have to be proportional. They have to have that same scale factor. And those sides have to be around an included congruent angle. Next, we have the side-side-side similarity theorem, and that says if the corresponding sides of two triangles are proportional, then the triangles are similar. So that means you have to look at the proportion or the ratio of each pair of corresponding sides and see if they have the same scale factor. If they simplify to the same thing, then your triangles are similar. So here we are going to determine if the triangles are similar, and if they are, we're going to write a similarity statement for the triangles. We will use the angle-angle similarity postulate, the side-angle-side similarity or theorem, or the side-side-side theorem. Now, for this one, I notice that they gave me only sides, so we are going to do this. We're going to check out the side-side-side similarity theorem first. Now, you're probably like, well, they're not oriented the same way. How do I know what matches up? That is a great question. What we're going to do is go in order. So ST is the smallest measure on that triangle. If the triangles are similar, it would correspond to VX or XV on the other triangle because, again, it would be the smallest side on the other one. So if we mark it, or we say ST is similar to, and it's going to be XV because S is connected to the longest side and X is connected to the longest side. So we got the same order. That is going to give us 6/9, or if we divide by 3, 2/3. All right, so now our next side that we're going to look at, let's look at the middle or the medium length side. So that is going to be, we'll do TU and VW. So we have TU over VW, and that is going to be 8/12. And we can simplify by 4 here, and that will give me 2/3. So that's encouraging. They are both the same scale factor. And then we'll look at our third and largest side next, and that is SU and XW. So SU and XW. So we'll do SU over XW, or W should probably be WX. But the side lengths are 10 and 15, and we can divide them both by 5, and when we simplify, we get 2/3. So I do know that the corresponding sides are congruent. So when we name it, we just have to make sure we get the sides in the right order, or the same order. So I'm going to go short to medium to long. So I'm going to do STU is similar to triangle, again, short to medium. So XVW. And again, you could do it in a different order, but just make sure you follow those corresponding sides. Right, next, we're going to look at indirect measurement. And sometimes when we are working with similar triangles, or we're looking at lengths that we can't measure easily, like, the top of a lighthouse, or the distance from a lighthouse to somewhere at sea, we can't always measure that easily, but we can use indirect measurement. And that often involves setting up a proportion with two measurements that we do know, and then the related measurement we can't find with another one we could find. All right, so here we have a rock climber, and he wants to know how high the cliff is he's going to climb. And so he places a mirror on the ground and walks backward until he can see the top of the cliff in the mirror. Something I would probably never think to do. It's very clever. So here's the mirror, and he knows he walks back 6 feet, and then he knows that the distance from the mirror to the cliff is 34 feet. So when I go to set up my proportion, I'm going to set it up. I'm going to do 6 feet over 34 feet. So let me... So we have our 6 over 34. Let me fix that, make that a 4. Okay, and then it's going to be equal to, now what we don't know, we know the height. He knows the height of the hiker. He knows his height. And that corresponds to the 6 feet there. So we'll put our 5.5 there. And then we don't know how tall the cliff is. So that's my x. So when I go to solve this, I am going to cross multiply. And that is going to give me 6x is equal to 5.5 times 34 is 187. Divide both sides by 6. And when we do that, we find that x equals, that is a decimal, it's about 31.16, repeating, but cliff height, we'll say it's approximately 31 feet tall. So he has to climb 31 feet to the top of the cliff. And that is it for 7-4.